So again welcome to my digital signal processing lecture series. So today here I introduce in detail of the architecture of TMS 320 family, which basically developed by the Texas Instruments DSP processor. Based on this slide, TMS 320 family, we are subdivided in two categories. One is 16-bit fixed point device, another is the 32-bit floating point device. When we are considering 16-bit, we are considering again the series, that is, we normally write down that is the TMS 320C. 1 series, C2 series, C2, C5 series, C54 series. Similarly, when we are considering for the 32-bit floating point device, that time we are considering TMS again 320. This is the family name. Like my family name is Chakraborty. So now the processor name, which basically here my name is Arindam. So here we consider like in that way. C3, C4, C6, very recently developed advanced processor C8. Now we are coming to the in detail. The Texas Instruments TMS 320 family of DSP device covered a wide range from 16-bit fixed point device to a single chip parallel processor device. In the past, DSP were used only in specialized applications. Now they are in many mass market consumer products that are continuously entering new market segment. Now we just move in detail of the 16-bit processor, which already mentioned earlier, that is C1, C2, C5, C54 in that processor. The wide of the data bus on those devices is 16-bit. At a time, their processor process the data with the 16-bit data. All have a modified Harvard architecture follow. They have been used in toy, hard disk drives, modem, cellular phone, and active car suspension. Now we just coming and specify the 32-bit. Like example C3X. The word of the data bus in the C3X series is 32-bit. Because of the reasonable cost and floating point performance, those are suitable for many applications. Those include almost any filter analysis, hi-fi system, voicemail, imaging, barcode reader, motor control, 3D graphics, or scientific processing. Now coming to the next 32-bit processor, considered as C4X. This range is designed for parallel processing. The C4X device have a 32-bit bus and a floating point. They have an optimized on-chip communication channel. The C4X range device have been used in virtual reality, image recognition, telecom routing, parallel processing system. Now we coming to the next advanced VLIW processor, that is the C6X device. This device developed by Texas Instruments, 8 functional unit includes 2 multiplier and 6 arithmetical units. So in case of TMS320C6 series having 8 functional unit includes 2 multiplier and 6 arithmetical logical unit, and it's provide MIPS of cost-effective performance. The C6X DSP are optimized for multi-channel, multi-function application, includes wireless base station, pole modem, remote access service, digital subscribe loop system, cable modems, and multi-channel telephone system. Now we come to the next series, that is C8X. The C8T is the first processor in this range. It has parallel processing on a single piece of silicon with 4 advanced DSP, or we call ADSP, and rich master processor. It is used in high performance video telephony, 3D computer graphics, virtual reality, a number of multimedia application also doing through this C8T or CX processor. Now detailing architecture, here we are discuss about TMS320C54 series. The C54 DSP use an advanced modified Harvard architecture that maximize processing power with the 8 buses. Separate program and data space allow simultaneously access to program instruction and the data. It has providing a high degree of parallelism. Now the C54 includes the control mechanism to manage interrupt, repeated operation, and function calling. Fixed point processor represent number as a magnitude and sign within a certain number of bits. Now here we discuss the bus structure. The C54X architecture is built around 8 major 16 buses, 4 program or data bus and 4 address bus. The program bus carried the, here example as a PB in the top of the figure, carried out the instruction code and immediate operand from the program memory. 3 data bus are considered, CB, DB and EB. Interconnect to various elements such as CPU, data address generation logic, program address generation logic, on-chip peripheral and data memory. 4 address buses are present, known as PAB, CAB, DAB and EAB, carry the addresses needed for instruction execution. The C54X can generate up to 2 data memory address per cycle using the 2 auxiliary register arithmetic unit considered as ARAU0 and ARAU1. Now coming to the internal memory organization, the C54X memory is organized into 3 individual selectable spaces: program, data and IO spaces. All C54X device contain both random access memory and read-only memory. The C54X also has 26 CPU register plus peripheral register that are mapped in the data spaces also. So coming to the next slide, that is basically the ALU functional diagram. Under the central processing unit on C54X CPU contain 40-bit arithmetical logical unit, 2 40-bit accumulator, barrel shifter, 17 cross 17-bit multiplier, 40-bit adder, compare, select, store unit. Specialized we call this is CSSU unit, data address generation unit, program address generation unit they have basically. Now we coming to the arithmetical logical unit. So the C54X perform 2's complement arithmetic with 40-bit arithmetic logical unit and 2 40-bit accumulator. Accumulator considered as in figure A and B. The ALU can also perform Boolean operation. ALU uses those input, that is 16-bit immediate value, 16-bit word from data memory, 16-bit value in temporary register called as T, to 16-bit word from the data. With this 32-bit word from the data memory and 40-bit word from either accumulator. Now we coming to the accumulator. As seen in figure, accumulator A and B store the output from ALU or the multiplier or adder block. They can also provide a second input to the ALU. Accumulator A can be input to the multiplier or adder. Each accumulator is divided into 3 parts, like low order word bit starting from 0 to 15, higher order word that is 16 to 31 bit, and guard bit for the overflowing cases 32 to 39 bits. Now we just moving to the barrel shifter, one of the most important part of the ALU functional diagram. The C54X barrel shifter has 40-bit input connected to the accumulator or to the data memory using CB or TB, and 40-bit output connected to the ALU or to the data memory using EB. The barrel shifter can produce a left shift of 0 to 31 bit and right shift for 0 to 16 bit on the input data. Additional shift capability enable the processor to perform numerical scaling, bit exciting, extended arithmetic, and overflow provision operation. Now we coming to the next part, that is multiplier and adder unit. The multiplier adder unit performs 17 cos 17 bit 2's complement multiplication with a 40 bit addition in a single instruction circle. In the C54X architecture, the 17 cross 17 bit multiplier is present to accumulated the ability to multiply a signed number by a unused number. The multiplier adder block consists of several elements: a multiplier and adder, sign unsigned input, control logic, functional control logic, zero detector, a rounder, we can say that 2's complement, overflow situation logic, and 16-bit temporary store register. The first on-chip multiplier allows the C54 series to perform operation efficiently such as convolution, autocorrelation, correlation, and filtering, etc. Now we coming to the next unit, that is we already mentioned CSSU, basically compare, select and store unit. The compare, select and store unit perform maximum comparison between the accumulator high and low word, allow both the test and control flag bit, that is called TC, in status register ST0 as in figure, and the transition register TRN to keep their transition history, and select the larger word in the accumulator to store into a data memory. Now also present on chip, I already mentioned previously that on chip and off chip ROM is there. So here we are considering on chip ROM. So for the on chip ROM is a part of the program memory space and in some cases part of the data memory space also. So now also present on chip dual access RAM, DRAM. The DRAM is comprised of several blocks like CPU, peripheral, host port interface like HPI, on chip single access ROM also there, SRAM. The SRAM is comprised of again several blocks like CPU, peripheral and others part. On chip memory security also present with the C54 is a maskable memory security option, protect the content of on chip memory are present on this processor. Now for the memory mapping register, the data memory space contain memory map register for the CPU and the on chip peripheral. Those registers are located on data page 0, simplify access to them. The memory mapped access provide a conventional way to save and restore the register for context switch and to transfer information between the accumulator and the other register also. The most interesting part, that is the addressing mode. So direct addressing block diagram here is shown. So their hardware is specifically different to the other processor. Here we have seen data addressing for a C54 offers 7 basic data addressing mode. Like a immediate addressing uses the instruction to encode a fixed value. Absolute addressing uses the instruction to encode a fixed address. Accumulator addressing uses accumulator A to access a location in the program memory and the data. Stack addressing manages adding and removing items from the system stack. With this, the most popular, that is direct addressing, is there. Indirect addressing there, memory mapping addressing also are present in this direct addressing block diagram with the dot addressing part. Now another most important part here we are seeing, that is pipelining structure. So any computer architecture or processor architecture, when we are discussing that time, pipelining is the most important part for the any processing unit. So here an instruction pipelining consists of sequence of the operation that occur during the execution of an instruction. The C54 pipelining has several levels up there: prefetch, fetch, decode, access, read, and execute. At each of the level, an independent operation are occurred. So last part we are discussing the serial port on the C54 vary by device and are represented by port types: synchronous, barrel, buffer, multi-channel buffer, MCPSB, time division multiplexing, that is TDM, are present. So all reference we are accumulate from Texas Instruments instructor's guide. So thank you for patience to consider my lecture. If you have any query, please mail me at arindam365@gmail.com. Thank you all.